I'll now talk a little bit about what we've learned about management of these systems. This is through our experiments, but also talking to the farmers we work with. The first message is use it or lose it, and that applies to both the saltbush and the understory. This is our research site at Yellering, and you can see the quality of the annual legumes we had at that site and what they are by the time we get back to graze it in autumn. So if you can utilise that understory by grazing it in spring and then come back for the saltbush and the residues in autumn. In terms of saltbushes that are ungrazed from year to year tend to drop their leaves and slow their growth rate. So here's some data from a research site at Tammin, where we have this darker line as the grazed shrubs, and this is a grazing period here where you can see that they were completely defoliated, another grazing period here. And this other line is adjacent shrubs where we fenced off and left them ungrazed. And the key message is that the ungrazed shrub tended to dump leaves in late autumn, and they tended to slow down their growth rate when they got to about 800 grams of biomass per shrub. So use it or lose it. Quick hard grazing will minimise selection. Here's another research site where we can see that the 3 shrubs in the foreground have been completely ignored while the ones behind have been defoliated. The more animals you have in there, the less chance they have of selecting shrubs. Having said that though, when we've tried to measure benefits of rotational grazing versus set stocking, the benefits tend to be quite small. And the only consistent benefit is in terms of wool production. So wool production from rotationally grazed animals the wool tends to be a bit stronger than those from the set stock plots. The key to profitability is the understory, so don't forget the understory. When setting up saltland pastures, consider where you can grow understory. If you can grow a good understory, plant less shrubs and hedgerows, for instance. Where you can't grow an understory because it's a little bit too salty, then go in for denser plantations of saltbush, but know you're going to be supplementing your animals. Just quickly, I want to talk a bit about what's next in terms of where we're going with our research program, and 2 of the projects we're working with is in Hards, which is investigating fetal and maternal training to reduce variation in intake, and also some work we're doing to improve old man saltbush. The Enhanced project, we don't have any data as such at the moment because we're in the middle of lambing. We're investigating the role of in utero programming, so pregnant ewes grazing saltbush during the last third of pregnancy, compared to ewes and lambs grazing saltbush prior to weaning, compared to a training exercise where animals will be given a grain reward when grazing saltbush. So we're going to investigate if any of those 3 tools will influence how much the lambs choose to eat in later life and how they utilise the saltbush in later life. The Old Man Saltbush Improvement Project, led by Peter Jessup in New South Wales DPI, aims to select higher value saltbushes for agriculture, and we've collected saltbush from across Australia. Over 80,000 plants have been collected, and they've been grown out at 4 sites in Tammin in Western Australia, Monarto in South Australia, and Condobolin in New South Wales. And the plants have been collected across the natural zone for saltbushes. In Western Australia we have 1 subspecies here, Spathulata. The East Coast has a different subspecies of old man saltbush. I'm particularly interested in organic matter digestibility because we want to see if we can lift the digestibility of saltbush from a maintenance diet to a growth diet for animals. So here are our 27 provenances and predicted organic matter digestibility on this axis. First thing we can see is that this group here in pink, which are the West Australian subspecies, have a much lower organic matter digestibility of leaves than the East Coast subspecies. Also within the subspecies there's variation in organic matter digestibility. So we've selected these highest plants and we're taking them forward in a selection program. We've also found heritable genetic variation in salt accumulation, sulphur and other minerals, and biomass growth rates. We can get 8 times the biomass growth from the elite genotypes. So what do the animals have to say? This is probably the first time in the world that animals have had a say in a plant breeding program right at the very start. And that's because there's lots of compounds in these plants that we don't understand and we don't measure. So we thought we'd let animals tell us which shrubs they prefer to graze. For these preference studies, at each nursery we grazed 18,000 shrubs, and each of the nurseries in Western Australia, Condobolin and Monarto, were grazed. You can see here 4 shrubs. They're from the same provenance as are these 3 shrubs, and that's the West Coast subspecies. This is the East Coast subspecies. You'll have to take my word for it that these shrubs here had as many leaves on them at the beginning of grazing. But within a week of grazing, the animals have shown clear preferences for particular shrubs. These preferences were consistent across the 3 sites. So the western subspecies again were relatively unpalatable or uneaten, and the East Coast subspecies were quite palatable, and there's quite a bit of variation in that palatability, and they're fairly consistent in the ones that they prefer to eat. Where we're going to now with this project is the elite lines in terms of biomass production, nutritive value and preference have been cloned, and we're now investigating those lines, hopefully for a commercial release in 2012, and releasing seed lines after that. If you want any more information about saltland pastures and how to manage them, a lot of this work is in the Saltland Genie, and CRC Future Farm Industries website contains a lot of information about the projects that we're running now. Thank you very much.